Okay, so hi everybody. Thanks for coming to my tech talk on a technique for testing called dependency injection, or at least the way I like to think about it is a way to turn your integration tests into unit tests. So we're going to talk a little bit about why, like what's the thing that we're trying to solve here, some strategies on how it's normally solved. And then we're going to get a little bit into the technique with some live coding examples and a ROS example. So why do we test? So we want to test because code is never finished, right? You write something and you never get to walk away from it, but it ships without you. So you want to be able to write as many tests as possible. So when you change things, you know that you're free to make those big changes that you want to make, or little changes with confidence. The thing is that it requires intent. You can't accidentally make testable code, at least in the ROS community. Probably most C++ programmers do, until you start actually getting into the parts that we're about to get into. And the reward for all this effort, because it is a lot of effort, I think anybody I've talked to about this has seen that it gets to be a lot of effort, is that empowerment and that freedom to be able to do the next step.
So, Chris, what's the effort, would you say, between development and unit test writing? Like, what ratio is it typically?
It wouldn't be unusual for me to have 4 to 10 times the amount of unit test code than actual like production code.
Wow.
Yeah. And some people know that I try to keep that test code relatively dense. So that's the non-boilerplated version. Okay. So the main problem that we're trying to solve here is something called side effects. So in programming, you usually think of something coming in and then a result being produced, right? And so on the left, we have something that I'm going to refer to as a pure function, right? Where the parameter list takes in, the X and the Y, right? And then returns, the result, whatever the result is. So this is the type of thing that you could easily see writing a unit test for, where like you put something in to get the right value. On the right is a side effect version of this code, where I take those two numbers and then it just prints it to, say, the command line, right? And you could imagine this being like some utility that you wrote up to do some calculation. You just want to see the answer, move on with your bash script, right? This code is much harder to test, because how do you actually get the result? Well, you probably have to scrape the bash screen, right? Or like write that thing to a file and then read the file and then see what the result is. You can imagine some sort of mechanism. So that's like the main thing that we're trying to combat here, right? Is these side effects. I mean, not combat, but like work with. If you've ever written a class, you've automatically written side effect code, because most of the time we write classes, they're not just for functors. Usually they're for taking some value, storing it for some amount of time, and then doing something with it later, right? So this is like obviously a very trivial example of that, where I'm just taking it, storing it, and then returning it. But the setter, for example, has an unobservable side effect, right? So we take that thing and who knows what happened to it. You can imagine that like there's some validation code here and you put it in and, oh, that thing doesn't have the range. Did it work? I don't know, right? And then our favorite example that everybody loves in this company, we get a thing, right? We do a calculation and then we publish it to ROS. And who knows if that worked? I know I frequently don't know. But that's a side effect, right? And that's like one of our main use cases here, is that we take things in from the middleware and we send them back out to the middleware, right? So there's a big usage for this technique to make tests like this easier. If anyone here has ever written a ROS integration test, right? Take some time to spin up a ROS core. Actually having to like set up those different nodes and then read it in can take some some non-trivial amount of time. How am I doing so far with everybody? You good? Okay.
This is entertaining. Thank you.
Sure. So how do we deal with this side effect code, right? So the first technique is not to be clever, right? So we write an integration test, as we kind of just mentioned. You would have the ROS code launch the node, right? You would have a publisher, right, in your testing launch file actually publish something. You'd receive it. You'd receive the publishing thing somehow, and then you'd see if that value was correct. I think most people are pretty familiar with that technique. So some shortcomings to that, right? It requires the entire context of what's necessary for that node to do just to test, say, if numbers were added, right? It is definitely, I'm definitely not advocating that you shouldn't have integration tests. They're very important because testing should be done in layers, right? So we should have unit tests, which are very fast, integration tests, simulation tests, and then on robot tests. But each one of those takes an order of magnitude or more time, right? So your integration test, your ROS test takes seconds, whereas the same test done in a DI way could take milliseconds, right? But the worst problem, if long test time was the only problem, then we probably wouldn't be having this conversation as much. The main problem with these integration tests is flakiness, which is actually an industry term I didn't know about. It means that if you run a test and it fails or passes and you run it again, you don't know that it's going to fail or pass, right? And that could be because CI timed out. That could be because your ROS2 nodes aren't configured in isolation, and so two tests are running at the same time and they're talking to each other and they interrupt things. There's lots of reasons why flakiness could occur. So that's one of the shortcomings, I'd say the main shortcoming. Another common approach that you'll see is making friends, because friends can test your privates, right? Or friends can touch your privates. So you would make a friend class. The friend class would have access to all the private variables. And then in your tests, that thing would operate your main class, your system under test. Obviously, it breaks encapsulation, right? So it tests the internals more than it tests the contract. One of the main problems, though, I see is that a situation where you would have not normally stored something, you are now forced to store it, right? So if it would have been natural for you to take something in and publish it right away, like we'll see, you will have to store that value and then later call and check that using the friend class. Does everybody kind of know what I'm talking about? All right. So yeah.
Yeah, it's good.
So there is a version of this that Abseil actually talks about, which is a little bit better than the default version. They're called peers. The end of this talk, I have all my links. Peers are basically the same thing. They just help with the test code into production code problem. Okay, so now we're going to look at the same code that we had in the beginning, but look at it again. This is slightly different, whereas the first case, S instantiated a node handle itself. Here, we're going to pass one in, right? Other than that, this doesn't look that different to anyone, I assume, right? This looks like normal ROS code. Yes, no? Anyone shaking their heads? Okay, cool. Wouldn't it be nice if we had control over N? If we could, like, ask N things and have N do things for us. If we had full control over what N saw and what N does, then we could probably test S much more easily. So if there's anything important, this is the main slide you have to come back to if you get confused later. What we're trying to do is we're trying to make N our class. Okay? Okay, cool. All right, so we'll get into the technique. Any questions before we do that? All right. So let's look at some toys talking about this technique. So I think you guys can see a compiler explorer screen, right? Yes. All right, cool. So we have a simple class here called, oh, sorry, this is the function version, right? So we have a simple function here called do stuff, right? And do stuff takes a printer and then it calls the printer with an argument, right? Does that make sense to everybody? Okay. So printer isn't a concrete class. It is a pure virtual abstract class. You can't actually instantiate one. In Java, this would be called creating an interface, right? Do stuff only takes printers, but we can make more than one printer, right? So we can make something that is kind of like boring print is print, right? Or we can make one that decorates the printing. So in this case, we're using couter, right, to do stuff. In this case, we're using sinker to do stuff. So the output, I don't know if I can enlarge that. The output for the first one is doing things, and the output of the second one is a decorated doing things. Makes sense so far, right? All right. Okay, so that first one was a function version of doing the injection, right? Seems simple enough. Instead, if we did that with a class, it might look like this, right? So we have this toy class, and the toy class takes a printer, and on construction, it prints something, and when it calls do it, it prints something. So here we're doing, you know, a couter again, right? And we're printing that we have a new toy and that we did stuff with the toy, right? But instead, if we had a sinker, right, we'd be decorating that. So it should be pretty much the same thing as we did before. Cool. All right. So with that toy example, we kind of like discussed two ways that you can actually give the printer, right, which for some reason somebody decided to call a dependency, because the full job of the class or function depends on the thing that you gave it. We, for terms of art, did a parameter injection version where we did it with just the function, and we did a constructor version, right? Makes sense? Yeah. There's one more called setter injection, which is basically parameter injection for a class. Though potentially you have to think about whether or not you've done a partially constructed object. Otherwise, it's just the same. Okay, so so far this has been pretty stupid, I guess. Like, why would we go through this amount of indirection? So we go through this amount of indirection so that we can utilize something called mocks. So in testing parlance, right, there's three kinds of test doubles that people talk about. So a fake, right, would be like setting up your own mini ROS parameter server, right, that isn't actually the production thing that you launch, but you would like actually hit that parameter server endpoint or action server, and you get those, you know, those resources from it, right? A stub is something very similar to a mock, where you would make like a little class, but it just has values right? So like I give you this thing, this is what comes out. A mock is a more advanced version of a stub that is used to verify behavior. So it will check to see if I called it with the right thing, how many times something was called, etc. Now I'm going to preface that this presentation is not on gmock. Gmock itself is worth a whole presentation, but this is where the crux of it gets to. So with gmock, right, and doing the toy example, then we can actually write g-tests explicitly using the mocking technique to verify the behavior, right? So here's our toy class again. This didn't change from the last slide where we're just taking the printer and doing a print, but instead we've wrapped it, right? We've wrapped it in this interface object that I've called world. So the world, again, has the print on it. This could be outside, but there's a discussion to be had about this world being only pertinent to this toy. So it would do all the same things that we did before, but this case for the mock, we can use gtest to actually make one of these mocks and then expect some sort of behavior from it, right? So for this test, we're actually going to expect that when toy is created, that it calls the print function. Can you guys see that okay? Is it too small? Okay. In the latter one, right, when we make the toy and we call do it, we can expect that print will be called, and then later we can expect that print will be called with a particular parameter. And so then these tests actually, run. So I can change that, and then the test will fail. The test will fail if I didn't actually try to print the thing I was supposed to print. So this is an example of how from the beginning slide, if you were trying to print something on the screen, how could you possibly test that? Everyone with me so far?
Yeah, I got a quick question. So your mock world, the mock method call in there, that basically defines this print, and it's just checking what gets passed to it?
Exactly. So this mock world, so this right here, John, is gtest boilerplate. You have to decorate, mock world with this macro in order to actually create a mock. But what that allows you to do is then allows you to do these expectations. So expectations, and then later we'll see, on call defining behavior. That then we can see that world object was called, had its print function called with a particular value. So, if in production you end up changing the way that world operates, you'll see that this test will now fail because the expectation is different. Okay. A little bit of more g-test here for you. Instead of expecting, you can also just define what the behavior is. So you can do an on call instead of expect call. And now I've lost people. Oh, crap. Okay, so back to the mock. In this case, I've made the world and I've added an additional prefix to the world. And I just want to see that getting of the prefix is called. So in this case, I'm going to say that, hey, world, if somebody calls prefix, give them this. And then now with that piece of information, when I do their expectation, I can make sure that they added the prefix that I told them to use.
I have a question about this. So, is it
Okay.
necessary for this technique for you to have an interface class?
Okay, so
Always.
we're going to go to a Ross example of this because I'm sure this is what everybody really wants to see. Is my screen being shared still? Okay. So I'm planning on, I tried to make this into like a container that I could publish on my GitHub. I'll continue to do that today and I'll send out a message to everyone Wednesday. But on the left here is, oh. Can you guys see? All right, so on the left here is an example of some very simple ROS class where we make this calculator, and this calculator is going to subscribe to a message, and it's going to take in the message, it's going to increment it, and it's going to publish it back out. So this should be something that everyone's comfortable with. We're using the in topic to subscribe and out topic to publish. Okay. So on the right is a dependency injected version of that. So instead of using the ROS object directly, we're going to make this handle object that will take a callback and do a publish. And when the calculator is instantiated, it's going to require one of those dependencies to be injected into it. And then it's going to operate using that class. So it's going to register that callback in its constructor. And then this is going to call doit. So when doit is called, then it's going to use that same middleware object to publish its result. So then down here in the actual node itself, we're going to make a new one of those. These are just decisions that I made for this class where that's how we get the topics, and it's taking that node handle there. Good so far? All right. So in the middleware object, you can see nothing very interesting is happening. So we have a constructor that takes a node handle, these topics, and then when you register, it makes a subscriber. When it's instantiated, it makes a publisher. When you call publish, it just passes that message through. So these dependency classes are intended to be very thin, almost non-existent. This technique would contrast the ROS wrappers that you might see in normal ROS code, where the ROS wrapper usually has quite a lot in it. Navigation, for example, has a ROS wrapper for its planners, and the A-star planners are, they have a lot of logic in them, but the wrapper for it also has quite a lot of logic, which is forced to be integration tested. In some cases, you can still test these. Sometimes they're so thin that it's just like saying, I'm just going to test ROS. But you end up having to write just a handful of tests, just know that you're calling the right thing. Okay, so then in the G test, you would have something like this. So we would have taken one of those middleware objects, and we would have created one of them. We would have captured the callback that the class was giving us, the calculator was giving us, so that we can operate it. Because really, that's what happens when you publish something to ROS. The node handle gets the callback, and then once it receives a message, it calls your callback with that. So then we can set up an expectation, right? about what's going to happen here with the publishing. So we're going to end up calling this with 7, and we're going to expect that we get published 8. We'll give the handle, the mocked handle, to the calculator, and then we'll call the callback. And so this test will then, verify that even though we gave it 7, we get 8 back. Does that make sense?
What's the difference between will once and at least?
So I gave this presentation about a month back, and the comment was I'd spent too much time on one thing and not left time for questions. So aside from the fact that we can talk about some details about owning or observing pointers, we can talk about that there's a templated version where this allows you to avoid certain discussions about wrapping ROS or wrapping someone else's middleware, where we can if we template our class, then it doesn't matter what it takes. So other than that, we can just start talking, asking questions, going back to certain pieces of code, because there's like 30 minutes left in this talk now. Nathan.
Can you hear us? I don't think you can hear us.
Wait, hold on. I can't hear people. Now I can hear people. Have people been trying to talk to me this whole time?
Yes.
No, just at the very, just one slide ago. You just missed one slide ago, so it was good timing.
All right.
Yeah, maybe.
Finish so quickly.
Yeah. Where do you guys want to go back to?
I think it was your editor, actually.
All right.
Is that a shared thing that you could paste the link into so we can all have it up at whatever Zoom level we want?
Right now?
Yeah, is it like GDB
No.
online where you can? Okay.
No. I could. This is several files right now. My plan is that I'm going to push this to a repo.
Cool.
The question was about will once.
Yeah,
Sure.
I was just wondering if you could give a real quick, there's the will once, there was the at least once,
Yep. Okay. So, right. So this is all gmock syntax independent of this particular technique. Mocks are really nice because you can set up kind of what you expect is going to happen. So yeah, there's a lot of syntax in here. What this is doing is expect call takes a mock object. So that's why this has to be dereferenced. And then is saying, hey, here's some mocked function on that object. In this particular case, fully qualified, this would be one of these. And it's saying that as opposed to the C++ variable named underscore, which is a very valid thing. We are saying, I don't care what parameter is being passed in here. Now, that's mainly because I was trying to make it a little bit simple. You can absolutely specify what parameter is being passed in here. And you can say, if it's a function, I don't care what kind of function is being passed in here. Then, once we're saying, expect some sort of call, the behavior here that we're saying is that only one time will this be called. But it doesn't have to be once. It could be, 7 times for some reason. But then this decorator is doing double duty. So this is both expecting how many times something's going to happen and defining a behavior. So there's another one here called expect repeatedly, right? However you spell repeatedly. Where every time this is called, this action is being done. So in another case, instead of doing invoke, it could be return, right? If you don't do, return by default, it'll return a default constructed object of whatever this is. register callback is void, so it obviously wouldn't return anything. But here, what we're saying is that the first time, the only time that you ever hear register callback being called, run this lambda. And obviously, it doesn't have to be a lambda. It could be something from test fixture that I'm given to do anything. And in this case, I'm just trying to capture the callback from the calculator so that I can use it later. Did that make sense? I forget who asked the question.
Yeah, I think I'm just not super familiar with the gmock function, so I just need to take a look at.
Most people aren't. I feel like that a lot of times what trips people up is that there's a lot of gmock syntax that makes this useful or even possible, right? Yep.
Gris, I have a question that you didn't hear earlier. So when you want to mock something, you basically always have to create an interface class, right?
Yes, unless you're doing the templated version.
Yeah, and so when would I want to create an interface to my class? Because it always adds like the hierarchy, class hierarchy grows in a way. So when would I want to do it and when would I want to not do it? That's something I don't fully understand.
No, that is an excellent point. It was something I had a note to bring up. So, and this came up in another project where I feel like people were actually starting to over-test using this technique. So as with, you call a function and parameters go in and then you inspect its return value, right? So should you only use this technique when there is a side effect. So if something is being printed, if something's being printed to the screen, if something is being sent to the middleware, that's where you want to receive that. As opposed to if you were trying to create like a shim in between, like maybe Yeri knows the particular person I'm talking about, where it's kind of like you're catching the internals, you don't want to do that. If your class is all about things going in and things going out, those are the borders that you want to kind of like do this black box testing is what it's called, and not have to know about the internals, because it can make your tests cause your implementation to be brittle. So for example, this calculator, right? I said that it incremented by 1. What if, for example, it had done, something like this? Right. Something happens that causes it to do it one way, and some other case does that, right? And I lost my screen again. Is it going to come back?
We can see it.
We can still see your editor.
I can't. Okay, now my screen came back. All right.
Just move where your cursor is. How about that?
Okay, right. So like this sort of thing happens, and so sometimes people might be inclined to inject another mock in here that, like, I don't know, ends up operating on that. Right? That sort of thing happens. And that's wrong. You shouldn't be trying to get into your logic in the middle, right? Nobody should care about how the data is being incremented. You should only care about what comes out to the middleware, or it goes into the middleware, or is something else that is essentially a public interface of the users.
I have a question, might be controversial. I normally cheat with the define private public, so I can just directly access everything inside. Just a devil advocate, one thing of, yeah, I know people looking at it like that, but one thing I do like about it, and with development, is if you take the robotics, you have an input output, but you might have like 10 functions inside that are actually quite complex. So you might take a laser scan and it might do something. And what I do it makes it a bit boilerplate. So for example, I will take a laser scan topic of a real robot. I'll make a big header message, and I will directly use the private public and pass in that laser scan into the function. So basically just instantiate the function, pass it into it. And then I can, in 4 or 5 places around, I can actually directly read the parameters to be like, oh, what is the, you know, let's take a LiDAR, and there might be inside the LiDAR callback, get closest object. And I could directly measure it, and I know I'm like, oh, the closest, because it's literally a static thing. I'd be like, oh, the closest one is 9.2 meters. Bam, I could just put my I use Gmod testing. I could just ask it, like, is it near enough 9.5 meters?
Right. So actually, Bren, that's not, so like the way you presented it sounded crazier than it actually sounded.
I think it's cheating with the private public.
It's not completely cheating, depending on how I look at your implementation. In an early version of this presentation, I discussed the pimple idiom, right, or some version of the composition allowing the stuff that would normally be private to then be public, right, to the class that's using it, right, where that implementation class that does all the hard math, you know, of a taking a message and then doing a calculation is exposed, but through like this other interface that isn't the ROS part, right? Is that what you meant?
Yeah, it's similar. It's more like, I see what you're doing here. This is more like, I use it quite often, because take this example where you're like, am I going to crash? It's literally a Boolean, but you have like 10 functions underneath doing like point cows and PLC. And unless you write so many tests, it's quite hard to see. It's like, because you're literally getting a Boolean out with so much data input. You might have like LiDAR, you might have a real sense. So I always cheat with the define pub, so I can actually just get in and actually see what real and it's also, I might be cheating. I could directly go and set a value that might be, you know, I could test different parts of the code internally of the function by just setting some external values. Might be bad juju, but I find it useful.
That one I might prefer to have a discussion with you with, but actually giving it, you know, laser messages and seeing what you know happens, that's just a different version of this technique, right? The only thing that I do kind of like worry about is, again, as I said about wrapper classes, where you are still having that full logic. The wrapper part tends to have quite a lot in it, and so if you don't have the exposure, you know, to actually give it full values, you have to have a real publisher or action server or something running to catch it. And then where is that guy instantiated?
Oh, one last question. This does actually seem quite useful. Is there a standard, instead of rewriting everything, is there a standard already done for just the node handler? Because I can see that it's a major one.
I haven't found one. In fact, I don't see a lot about this particular technique in the ROS community in general. This was a technique popularized by the Java community, so probably not a lot of C++ guys, you know, get into this, although I have other resources about people making kind of like API objects that keep getting, you know, reused in C++ for this technique. I should mention though, this is something that we used at my last company, which was completely ROS based, in as many places as we possibly could, right? So this isn't like a theoretical, you could use it for ROS. We used this for ROS on 700 robots.
ROS 2 has a handful of interface classes to the node object, and you can actually ask the node object to give you a pointer to itself as one of these interface objects. And so if you take the interface object as your input to your subsystem, then it looks very much like they're providing this mock interface, or this interface that you could implement differently if you wanted to.
Okay, so is it pure virtual?
Yes, there's a pure virtual interface that you can ask for. You can ask for a pointer to that from any node object in ROS 2.
Well,
and then
Bren, I'm not a ROS2 person. If I'd known that, then you could probably just do half of that. You probably would get rid of a whole bunch of boilerplate just by being able to have that interface.
And there's a handful of like split up ones. Like there's one that only has all the parameter interfaces, and there's one that only has all the like pub sub interfaces. So if you wanted to give your class like limited access to the node, you could.
So maybe Tyler can work with Grizz on the ROS2 branch of this sample repo, and then we'll have the ROS1 one, and then we can do a blog post about here's another reason to start doing ROS2.
That's true. Bren, this would be kind of like getting away from having to have that interface, because there's just a templated version of doing that. So if you just take it as a template parameter, then you never have to write an interface class.
All right. Oh, it's just I don't know. Is there any way of just like overriding the ROS node handle and make a fake header file and point to that? But that could be a bit too dodgy.
I think that's kind of like what we're trying to do here, where we're trying to be, where we're trying to wrap the, the node handle, right?
Yeah.
There's probably some way to template syntax to specify that T must provide all the interfaces that you need. So
probably in like 20, right?
Yeah. There's a whole bunch of stuff that was even just added in 17 so that you can your template can require certain interfaces.
I think this might be a little tricky in ROS2, actually. I'd be interested in exploring it further, because for ROS2 nodes, I think the way they want you to do it is to have your custom like business logic like extend the base node class, because then you can have it be like a composable node in a container. And that's not really equivalent to this approach that you show that's common for ROS1 nodes, where you have a node handle that you pass in and then do all the stuff to the node handle. So I'd have to research a little bit to see how you do that, but it sounds like something you've thought about. I've seen mock code and some of like Arvis 2, for example. So
it's possible that there's just like because they did certain design decisions, then you can just take more advantage of mocks directly without having to like put something in between, right?
Mm-hmm. Yeah.
Joe, as far as inheriting from the node object, you don't have to. You can make a component without doing that.
Okay, that's probably the better way then.
Even though that's their example, and their example is welcome to ROS2. So
I have an example or a question. I recently had a move it thing where there was a double input to a function, and we screwed things up because we passed nan, and so I added a check to see if it was nan or not, and if it was, it threw an exception, and that was easy to test.
Yeah.
But it was also a value that was probably supposed to be between 0 and 1, but there are feasible cases where you would put something else in there. And so I had it print a warning to the ROS console, and so I wasn't able to write a test for that easily, because I didn't want to like subscribe to ROS out and look for my warning coming out.
Yeah.
Would there be a more straightforward way to do that using?
I'm not sure, because those logging functions are macros, right? What you would have to do with this technique is that you'd have to send your log message through the the injected dependency, right? You'd have to send it through the handle instead of calling ROS info or ROS warn directly.
Well, could you configure the launch file to print to console, and then it'd be going through cout maybe, and then this would work, or the traditional thing would work, or?
Then you would have to
yeah, that might be worse.
Yeah, it might. And cout has some initialization stuff.
Yeah, I ultimately decided that the best thing to do was to not test that behavior.
Right.
There might be some log4j thing you could do, because it's all based on log4j. You know, it's supposed to be agnostic. Rust log is based on log4j.
Right.
You could, like that macro expand to something. You could look at the precompiled output and see if you could figure out how to hack what that macro is going to expand to.
Integration tests, though, obviously still have a place, Tyler. So maybe that's that sort of case, or you could just capture it. In the last 4 minutes, does anybody else have any questions about anything I showed here?
Because I'm thinking about it, the way I tested, I said before, it's quite simple, pub and sub. I was wondering, actually, more complex rosting. Have you actually used it successfully, like TF transforms and like? Because I could see that. How would you actually do a testing with all those functionalities?
Well, so the whole point of defining the interface, right, is that you're trying to tell it, these are the things that I'm going to want to call, and these are the things I'm going to want to return. So underneath the middleware handle, right, it would call TF and do all the complicated things. I imagine this thing would end up holding the buffers, right?
Oh, yeah. So you'd have to write all of this for a buffer, the TF, and try and mock all of that and just be like, all right.
But as far as this guy is concerned, it would be getting in, getting out. Usually we use this with action servers.
So if it needed TF, would that be more in the realm of integration? Integration test would be more appropriate?
No, I don't think so, because what you would do is you would build that part into here, and then you'd do the integration test for this class using the normal TF stuff, right? The normal ROS test to set up those TFs and see that they return correctly. But then your class that's actually doing the work with that information would just get either a correctly transformed thing or an incorrectly transformed thing.
Okay, I have another hypothetical. Let's say I wanted to test and move it servo that it is correctly measuring the staleness of the last received message and decelerates to 0 the commands going out. What would be the most appropriate way to test that? So like if it hasn't received a message in 100 milliseconds or something, it starts saying like, I've lost connection, decelerate.
You would mock the timer so that you could just.
I guess so. It would be
ROS timer so that you could just implement the function, the dozen times or whatever you need for it, or you could call the function a dozen times instead of having to wait for a dozen calls of the function. You would mock the timer.
So that DI would be more appropriate. So DI would be more appropriate than an integration test.
Yes, because you would go ahead.
I was making a joke. I said unless you want to put sleeps in your test.
Right. So that would be on the integration test side then. But here you would see like, oh, it got called this many times, or in sometimes the code would be like this timestamp versus this timestamp, right? And then it would be doing that measurement, because ultimately when you call ROS time or I guess the rate thing is what you're probably getting at, right? Where you have it and it sleeps and it's in that side that spinner, right?
Yeah.
Yeah.
You don't want to test the one thing, right? An important part of testing is separating what you're actually testing, Nathan. And you don't want to test the CPU performance or RAM performance of the test runner. You would rather test that your code performs correctly. And so it would make a lot more sense to me in that case to mock the timer, the ROS timer, so that you could just invoke the callback of the ROS timer however many times you need to, and then check that the state changed in the way you expect.
Yeah.
Instead of starting a ROS timer, waiting a certain amount of time, and implying that in that amount of time, the timer got invoked a certain number of times.
Right. So essentially you'd have to have a now function here.
Yeah.
Right. You'd have to have something like that, Nathan.
Yeah.
Or
cool. Yeah, that makes sense.
Yeah. Okay. So we're out of time. Obviously, anybody who wants to like ask me any questions can message me, and I am going to try to put this up. I think the slides are something that people have access to. If not, I'll talk to Cassidy.
Yep.
About making sure that's there, and that has the compiler explorer links built into it.